Hi everyone. This video is going to show how to solve a log equation where the first example I have the log equation with a different base, and the second example is about the indices equation where I'm going to convert this indices equation into the quadratic form. And for the example, the third example, I'm going to compare both sides, and later on going to solve for the x. This is about the indices. And the fourth example, which is the last example of this video, is about the log equation, and we need to express x in terms of a. Let's look at the example 1. To solve this equation, we need to make them to have the same base. Since the first term having the base of 8, so I'll just remain it as the base of 8. But for the second term, I'm going to change it into the base of 8. And up here will be 64. Down here will be x. Constant just remain as constant. And later on, I'm going to multiply both sides by log x to the base of 8, so that this denominator later on will be eliminated. So when you multiply the first term by the log x to the base of 8, this will become x base of 8 square minus 64 can be written as a 8 power of 2. So follow the laws of log. You can bring the 2 to the front. You got a 2 multiplied by log 8 to the base of 8. All right. Then you have a 2 actually. Then the denominator is actually cancel off with the log x to the base of 8. And you will have a negative 2 for the second term. And the third term, when a 1 multiplied by log x to the base of 8, you will have a log x to the base of 8. And this is equals to 0. Later on, we can substitute this a as a log x to the base of 8, and you will rewrite your equation in terms of a. This will become 3a squared plus a minus 2 equals to 0. Then you can see that this is a quadratic equation. You can use the quadratic method to solve for the equation. So to get a 3a squared, this will be 3a, this will be a, and the 2 will be located here, and the 1 will be here. To get a positive a, we have to take the positive 3a minus 2a to get a positive 1a. And later on, we're going to check by expanding back. Okay, check whether our expansion is it tally to the expansion. Then after that, we have a equals to 2 over 3, a equals to negative 1. Substitute back the a as a log x to the base of 8. Okay, then solve for the x. How do you solve for the x? You are going to convert this log equation in index form. Then this will be 8 to the power of 2 over 3. You can actually simplify this by converting the 8 into 2 power of 3. Then using the rules of indices, the power can be multiplied each other and cancel off the 3. You got 2 power of 2, that will be equals to 4. And for the 8, a equals to negative 1. Again, you will substitute the a back to log x to the base of 8. And this is equals to negative 1. Then you have your 8 power of negative 1. By converting this equation into the index form, you got this. Finally, simplify it, you will have a 1 over 8. So again, you have a two solution, right? Two solution, you need to check whether you're going to accept both of the solution, or it might be only accepting one of it. So how can we do that? How do we know we will accept both or either one? We're going to substitute the value. Let's say we check for the x equals to 4. When the x equals to 4, you will calculate the left-hand value, see whether it is equals to 0. If yes, then you will accept the 4 as your solution. All right. After that, you are going to substitute x equals to 1 over 8 after that. All right. Check whether the 1 over 8, okay, when the x equals to 1 over 8, left hand value, is it equals to 0? If yes, then you're going to accept the 1 over 8 also. So now we're going to check by using our calculator. So from the result that I have used my calculator, I have the value of 2 for the first term when x equals to 4, and the second term produce 3 when x equals to 4, and the last term is 1. So you will have a 2 minus 3, that is negative 1. Negative 1 plus 1, that will be equals to 0, and which is equals to the value of the right hand side, meaning that we are going to accept this as our answer. That is x equals to 4. Then now we check for the x equals to 1 over 8. When x equals to 1 over 8, I got my first term, produce a negative 3, second term negative 2, and the third term is a constant. So you have a negative 3 plus 2, negative 1, negative 1 plus 1, again is equals to 0. So conclusion, we will accept both of the solution as our final solution. That is x equals to 4 or x equals to 1 over 8. To answer the second example, and we're going to solve for this index equation. Here we will split the 4 power of 2x plus 1 into 4 power of 2x multiplied by 4 power of 1 minus 65 4 power of x plus 16 equals to 0. So you will have a 4, and 4 power of 2x can be rewrite as a 4 power of x power of 2 minus 64 multiplied by 4 power of x plus 16 equals to 0. You will see that this is actually in a quadratic form where you can substitute the a as your 4 power of x. Let a to be 4 power of x, then all your equation can be written in terms of a, that will become a 4a squared minus 65a plus 16 equals to 0. Factorize to solve for the a first. We have a negative, negative, and maybe we can expand it back, okay, to check whether your factorization is correct. Then after that, you solve for the a. You have a equals to 1 over 4. Another a will be equals to 16. Substitute back the a as a 4 power of x. You may rewrite your 1 over 4 into 4 power of negative 1. Then you compare both side of the equation. Then you will get the x equals to negative 1. The same things will apply here. 4 power of x equals to 16. Rewrite your 16 as a 4 square. Then compare both sides, compare the power. You will have your x equals to 2. So basically, you will have two answers for your solution. That is x equals to negative 1 or x equals to 2. This is a third example. To solve this indices problem, I'm going to simplify the left-hand side and the right-hand side separately first, because what I can see is the 3 and the 9, both of them can change to both of them can be the base in the base 3, and 27 and 729 also the same. So before we combine them, we can always write your 9 into the 3 power of 2 power of 1 minus x. And 27 always can be rewrite as a 3 power of 3, and this having the power of 4 plus 3x. 729 is equivalent to the 3 power of 6. Okay, so everything is already in the base of 3. Now we can combine these two by taking the 5x plus 2 minus the power at the denominator over here. So this will become a 3 power of 5x plus 2 minus, okay, this is producing 2 minus 2x. So I'm going to take the minus 2 minus 2x, all right? And then the right hand side will be 3 power of 12. 3 multiplied by 4 is 12 plus 3 multiplied by 3x will be 9x, and minus 6. I'm actually applying the rules of indices. After that, simplify the power. I got 5x plus 2x, that is 7x. 2 minus 2 will be 0. And at the right hand side, I got my 9x plus 6. Okay, so now you can see that we have simplified our equation become this, both having the same base. Then we can solve for the x by comparing the power, or we equate the power. That is 7x equals to 9x plus 6. This is the last example in this video. The question is asked us to express x in terms of a. So we can actually remain the left hand side and combine the right hand side to be a single log. So when we want to combine it become the single log, we must make sure the 3 must be moved up here to become the power first. So it become 2 power of 3, and the second term of the right hand side will remain unchanged. Then we're going to combine these two terms together. Because of the operation minus here, we're going to take the 2 power of 3, which is equivalent to 8, divided by x minus 2a. Okay, this is according to the second laws of log. And the left hand side, just copy it down. Then now we can see that left hand side and right hand side having the log term, single log term, and both of them having the same base. We can compare the content of the log by taking the x over a square equals to 8 over x minus 2a. And the question asks us to express x in terms of a. We will make it, we will cross multiply. We got that x multiplied by x minus 2a equals to 8a squared. And for the x multiplied by x minus 2a, we are going to expand it. We got a 2ax minus 8a squared equals to 0. So obviously this become a quadratic equation where we can factorize it. X, and 8a squared consists of a 4a multiplied by 2a. In order to get a negative 2ax, here has to be negative and here has to be positive. So you have your x equals to 4a and x equals to negative 2a. All right. And we're not going to accept this answer because we know that the A has to be positive because the A is a base of the log. It has to be positive. So if negative 2 multiplied by A, it will produce negative number. All right, negative value. So when the x equals to negative 2a, we just substitute this one of the term in one of the term of the log. If the x equals to negative 2a, this become a negative 4a, which log is not allowed any negative number over here. So we're going to discard the x equals to negative 2a and only accept x equals to 4a. And going back to the question, we need to express x in terms of a. So this already satisfied the question, means that this is already in the form of x equals to 4a. All right, thank you for watching.